In this tutorial, we're going to take a look at what mapping rules are for a translation. And there's different kinds of transformations besides just translations. There's rotations, reflections, dilations. Mapping rules work very similar for those, but I'm just going to talk about translations for this particular example. So we have this original triangle, ABC here, with these 3 points as its vertices or corners. And this is its image, and how I know that this one's the image is because of these primes. A prime, B prime, C prime means the image of A, B, and C. So let's take a look at the actual ordered pairs. So for example, A is the point 3, negative 1. And it changed into this point, negative 3, positive 1. B was the point 7, negative 3, and it changed into this point 1, negative 1. And C was 1, negative 6. C prime is the point negative 5, negative 4. Well, what exactly happened to those numbers? And a hint, translations is all about shifting right or left, up or down. So it's all about adding or subtracting numbers. There's no multiplying, dividing, switching things. Okay, it's just adding and subtracting. So if you think about first of all, the x, 3 changed into negative 3, 7 changed into 1, 1 changed into negative 5. And it's 6 that you subtract from each of these numbers to get the new x. 7 minus 6 is 1. 3 minus 6 is negative 3. 1 minus 6 is negative 5. And if you look at how this triangle shifted, see it went left 6. So that's why all the x coordinates have 6 subtracted from them. Now the y coordinates, look at them. So negative 1 changed into positive 1. Negative 3 changed into negative 1. Negative 6 changed into negative 4. And if you look at the graph here, you see not only did they go left 6, but they went up 2. See, this point went left 6, up 2. B went left 6, up 2. So you see, if I add 2 to negative 1, I get 1. If I add 2 to negative 3, I get negative 1. If I add 2 to negative 6, I get negative 4. So this is what, and translations are often illustrated with an arrow. So it shows how it moved. This point B moved to here. This point C moved to here. So all of those arrows are moving 6 left and 2 up. So how we write the mapping rule is this. So all mapping rules start with the point x comma y. It just represents a random point on the xy axis. Remember, this is the x-axis here, this is the y-axis here. And because all the x's had 6 subtracted from them, for the x part over here, I write x minus 6. So x is the original first number, so we're going to subtract 6 from it to get the new image's x coordinate. All the y's were increased by 2. We added 2 to them because it went up 2. So we have a y here, so over here we put y plus 2. So that's what the mapping rule looks like. And if I just look at the mapping rule, even without the graph, see x changes into x minus 6. So that would tell me it moves 6 to the left because we subtracted 6 from all the x's. The y changed into y plus 2. See, plus is an up direction. So that means that the graph would have moved up 2. So left 6, up 2. So that's what mapping rules look like for any kind of translations. There's always a number added or subtracted to the x values. Actually, I shouldn't say always. You could, for example, let's say just move 7 units and not move up or down. If you didn't move up or down, then the y would still be just y over here. You could, for example, take a point and not move left or right, but just move up or down. And in that case, if we had an x at the beginning, actually, I'm going to write those. So I just wrote 2 examples here. So let's say your translation was just to move right 5, not moving up or down at all. Okay, so if we're moving right to the 5, that means all the x coordinates are getting to be 5 bigger. So we would put x plus 5. And if we're not moving up and down at all for y, then see, y was y here. It's exactly the same here. So we would just put y in the end. If instead, let's say we were just moving down 3, So we're not moving right or left at all. So in that case, the x would stay the same. And if the y's are all going, if the whole thing's going down 3, all the y coordinates, then in that case, we would be subtracting 3 from all the y's. And that's what the mapping rule would look like. So you don't always have to have a number added or subtracted to all the x's and all the y's. In some cases, if you're just doing a right to left or just an up or down, then one of the x's or y's hasn't had anything done to it, so it would stay the same. And that's the end of the tutorial.